Good afternoon. Thank you all so much for being here. Welcome to our 16th annual Smart Energy Summit. I'm going to grab your attention here real quickly. Thank you. I'm Elizabeth Parks, the President and CMO of Parks Associates. I'm really excited about our keynote speaker today. And so thank you for your attention. I'm happy to introduce Will Dillon. For the last 2 years, Will has served as CTO at Savant Systems, a global leader in smart home, intelligent lighting, and energy solutions for consumers, businesses, and more. A pioneer in the field of energy automation, Will has 5 patents in flexible load management, intelligent circuit breakers, a smart light switch thermostat for energy management and control, and dynamic microgrids. He was part of the founding cohort and the former CTO of RacePoint Energy, the startup that created the power management technology used in the Savant power system. I'm excited to hear more from him today on the history and the next generation of smart homes. Please join me in welcoming Will to the stage.
Thank you, Elizabeth. I appreciate the introduction very much. And thank you, everyone, for being with me today and hearing my little talk. So I know that some of you probably already know a little bit about Savant. Elizabeth also explained some of the key facts. But I want to spend the first half of my talk sort of getting the fuller story of Savant. I know there's probably new people here that are unfamiliar with some of the background, and sometimes we don't always go through all of this history with people we talk to, so you may be familiar with this but not familiar with sort of the journey. And I think the journey is actually pretty interesting. The founder, CEO, and a lot of the founding cohort of Savant Systems came from telecom. So in the 90s, there was a telecom deregulation boom. They just happened to be in the right place at the right time with a intelligent telecom switch. That kind of grew up, in a good way, and they were purchased by Lucent in like 1998, 1999. So the founder and that team did really well, and when the founder was Bob Dillon, and he was building a new house, like an apartment in New York, and at that time, smart home didn't really exist. There was AMX, Crestron, but those were really commercial property, like event management systems, conference room systems, things like that. And so in his apartment in New York, at his kitchen table, every day for weeks and weeks, there's this programmer, this AMX program, I think it's AMX. Programmer sitting on the table, like programming how to have his TV turn on when he uses his remote control. And he got super frustrated by that. And he's like, well, I can do way better. We did this thing at Lucent or at Excel where we had this cool programming language that let telecom set up their switches in this fast and easy way. I can do the same thing in smart home. And so that's what they did. They developed something called Blueprint, which is like a drag and drop programming model for smart home. They were able to profile TVs and VCRs and these just at the time, DVD players and stuff like that. And I really just kind of grew from there. And the smart home, residential smart home market grew with that. We can fast forward to 2014, and Bob hired William Lynch to be the new CEO of Savant, and he'd bring that down into more typical homes, what we call mid-market. And Bob knew that the only way he was going to let this new CEO do his job without somebody constantly like hovering over behind him was to go and start a new company. And at that time, he was building a home, he was putting solar on it, and he was talking to solar installers, and they said, look, you just have to know that if the grid goes down, none of this will work. The solar is not going to work. And he's like, that is ridiculous. That's the stupidest thing I've ever heard. That is completely unacceptable. And so at that time, that's when he started RacePoint Energy. So it was about 2 years, super stealth. He was doing market studies, working with a woman, Anna Demio, sort of figuring out like, oh, I think there's a market here. I think there's a business model we can make this work. And so in 2016, that's when I joined RacePoint Energy, when we started our founding company. So it was me, focusing on software engineering, mechanical engineering, electrical engineering. Super tight team, super focused on building a load control engine. So I mentioned that was in 2016, and so Lumen was also founded in 2016, and Spanish founded in 2018. So like we were right there, like at the same time, literally in Spain developing smart energy. We actually were first into market with our companion modules. Okay, a couple years after that, Savant bought a bunch of companies, a bunch of lighting companies, 4 different lighting companies. RacePoint Energy, the energy company that I was in, and also a battery inverter. So we took that smart home, and then we made it smart energy, smart home, all in one unified platform. Okay, so the thing that makes Savant a bit unique in this market segment, in the smart energy market segment, is the fact that we've got such a deep history in smart home. We have 10,000 profiles, and the profile is like a specific make and model of TV, or a specific make and model of security camera, or doorbell, or any of these things. Every one of those product SKUs, or sometimes a product SKU class, is a profile. And we've got 10,000 of those. And that's, across 100 vendors and like 16 profiles, or like, not 16, multiple dozens of protocols like Wi-Fi, Matter, KNX, Zigbee, LAN. It's tons, right? So this history gives us all of this backlog of integrations that we can take forward into smart energy. And so because of that, we can make the entire home smart energy aware. Anything in the home can effectively be managed in a smart home aware or smart energy aware way. So the opportunities here are almost endless. You can think about passive solar with shading and lights. You can think about energy responsive thermostats, that's kind of a gimme, but you also do even circadian rhythm lighting, which is something that Savant has recently introduced. And just trying to miss anything. We also do EV charging based, optimal charging based on grid costs or grid energy costs, battery state, things like that. And because we have that history, so far Savant is like one of the strongest positions to do that. There's a lot of new smart home companies, like I think the panel, first panel today, that a lot of that was discussed. Now, while smart control is amazing and great, sometimes it's not always available. So, Savant's smart energy modules are that bridge that closes the gap between things that we can control with digital means, Wi-Fi, all those things, and existing loads that cannot be controlled that way. So you can't always control your pool pump that way. You can't always control legacy appliances that way. You can't always control large loads via smart means. And so while we were at RacePoint, we developed these companion modules. And these are called companion modules because they're not actually a breaker, though they are approved to be mounted in standard breaker panels, QO, CH, BR, etc. And they're wired in series with a traditional protection breaker. So the protection breaker provides thermal, magnetic, AFCI, GFCI protection, and then our module provides disaggregated behind the meter load, measurement, and control. Okay. There are some drawbacks to products like this, and it's shared across all of the similar products between Span and Lumen. And that's that you're controlling things at only a certain level, right? Like you can't go into the south bedroom lights and plugs circuit and then control individual things with circuit level control. And another consequence is that circuit level control can be confusing and intimidating to users. Right? So if you talk to electricians, they'll kind of joke about how that big 200 amp switch at the top of the breaker is like the safest switch in your house. You just hit that switch and the house is like instantly safe. There's no electricity in the whole house. But as an end user, you're completely terrified by it. Because it's this big, scary switch in the breaker panel. And like the other switches have sort of a similar like gut feeling to end users, people that aren't familiar with it. And so even though it's smart control via these nice LCDs in your phone, it can still be intimidating to work with circuit control level. And another drawback to circuit level control is that all of the appliances that we end up controlling, those appliances are designed by product managers and engineers that understand all of the delicate nature that these appliances require to operate safely and optimally. As a concrete example of that is remote control ovens, washers, and clothes dryers, right? So we work with our partners a lot, and when we work with GE Appliances, for example, we talk about how we should do energy management with their products. And they'll always say, oh, sure, well, you can turn off our power. We have to understand that if somebody wants to do a remote start on their dryer, we have to prove, essentially, that there isn't a child or a cat or any other in the dryer, right? So the way that you do that is you close the door, you request remote start, and then the door either locks, or if the door is open, you cancel the remote start, right? So that's a way that they have this chain of safety between a human operator at the device, making sure it's safe, and then maintaining that safe state through the time the remote start happens. So if we wanted to do energy responsive smart control of the dryer, for example, we can't just shut off the load, when energy is cheap, turn that circuit on and have the dryer start. It has to be done through a smart means so that chain is maintained. Meanwhile, things like HVAC, I think are a really interesting use case in this, where in the past, thermostats were really just a mercury switch on a little bimetallic strip, right? So the user would move a little lever on the thermostat, and the bimetallic strip, which is like a way to change shape when things get hotter or colder, would tip, and the mercury would slide down and would turn on the cooling. That's like in the old times, right? And so your air conditioner in the backyard or the side yard or whatever, it really can't be started and stopped all the time. So there had to be some place where you would give that 5-minute waiting time or that safe cool down time for your air conditioner, and that was the ultimate interface, right? The furnace had a control logic board that would take that sort of dirty input from the thermostat, clean it up, make it safe, and ensure the safety of its own equipment and the equipment attached to it. And these days, it's not like that at all anymore. We have mini splits and inverter ACs and really complicated and interesting furnace systems, and those kind of have to be smart controlled, right? So to make the most out of your inverter heat pump, you can do tricks with measuring the freon pressure and things like that, but it's better if you have the exact temperature or the temperature trajectory and watching the delta T and things like that. And so we have to do smart control there too. And then finally, the last example I have is AV remote controls. And with AV remote controls, it used to be you could just have a little sensor that watched the infrared codes, when you press the button on the remote control. And I don't know if you've all used the Logitech smart, programmable remote controls. You can just program it like that. And that is almost all gone. It's all wireless or Bluetooth, Wi-Fi or Bluetooth for your remote control of your TV, so you can get things like voice, things like that. You just can't do it overnight. So we have to have smart control there too. So increasingly, while we do have more opportunities for doing smart energy in the home space, we have to do it in these smart, we have to sort of mitigate it with digital protocols and things like that. So there's a downside to smart control, and it's a 6-part downside that I'm going to touch on each one. So on the one hand, when myself as like a representative of Savant, I talk to anyone of the potential partners in the room, I will say, hey, I'd really like to work with you. I think it would be great for both of our companies to develop a profile and expand our capabilities. Well, the first conversation is, cool, let's get an NDA signed. Right, so then we have to do NDA. Whose NDA is it? How long is our legal team going to take to check your NDA? It could be weeks, right? That happens. And then, meanwhile, we're all in competition. Like, we're all not always competing with each other, but there are definitely friends in the room. And so we have to navigate that delicate competitive relationship between our entities. And then once all of those things are straightened up, we have our totally stressed out and overworked engineers that actually have to do that work to implement that integration. And then we have bugs. Everybody loves bugs. I do want to, really quick, there was International Women's Day a couple of weeks ago, and that photo on the bottom left is a photo of the notebook of Bert Hopper, who's like one of the founders of computer science. And that's a moth that she found in a relay computer that she was working on. And so we get the word bug from Grace Hopper because she found a moth. So anyways, there's bugs that we have, and those are super fun to work with. And then this middle one is kind of silly, and basically what that is I want to talk about incompatible versions, right? So we do our integration, we've gone through testing, we found all of our bugs, but we have independent companies with independent agencies. And so, one company might update their API, but we haven't updated our API yet. And so things that we're working may not continue to do. And a lot of times when I come up with these pictures, I'll just type in the thing I want, the picture I want, and put it into Google or whatever, do image search, and see what other people use in their slideshow, and it came up with nothing. So I was like, okay, well, I guess it's meme time. And then finally, we have networking. So networking is super, super hard. Now I know that from a professional perspective, networking is kind of not that big of a deal. But when you work into individuals' homes, networking becomes super, super hard. Because everybody's got a different network provider. They're all set up different. Some people don't have that good of coverage, so they have mesh Wi-Fi that doesn't always work right. And probably 2/3 to 3/4 of the support calls we would get at Savant ultimately boil down to network issues in the customer side. So networking is easily the hardest part of this entire conversation. Okay, so I think we find ourselves at a bit of a fork in the road. On the one hand, we have smart appliances that do such amazing things, being able to be energy. We have greater customer awareness of energy than ever before. More and more people want to be smart with their energy. They want to be able to participate in this solution. And utility programs are better than ever, and they're always getting better. But we also have entrenched platforms. We have things like Amazon Alexa, we have Google Home, we have HomeKit that are some better than others, but they're difficult to work with, and the companies can be difficult. Also, customers are expressing that they're experiencing subscription fatigue, right? So how many times have you wanted to get a new product or with something like, oh gosh, subscription? Forget it. I'm over it. I'm done with subscriptions. And similar to entrenched platforms, we also have a lot of monopolistic behavior in the industry. Same kind of companies, same kind of issues, and there has been some good things with the FTC in the past. I'm not sure that's going to continue very much in the future. And we have a bit of a fractured marketplace, which I think is actually a good thing. So today, there's I think probably 3 or 4 different companies in the room that do DERMS platform management. Right, so there is, and multiple utilities also sometimes have their own programs that are not necessarily compatible with ours working directly with vendors. While that's confusing, I think it's positive, but it can be very confusing to consumers. So I want to spend just another moment arguing on centralized platforms. This is sort of one of my hobby horses. The model of a centralized platform is this sort of 3-step system. So if you look at Amazon, this is sort of what they did, Lyft, Uber, etc. Right? So you start with VC money and you do blitzscale. So you start with VC money, you undersell your product and get customers to join. And this is the most amazing thing, look at how great value this is, I love this platform. And then once you get customers sort of engaged by your platform, then you can turn the love on to vendors. You can provide really easy integration with logistics, payment processing, reduce complexity by implementing difficult regulatory parts of the stack. And then once you get vendors dependent on you, then you can turn it on yourself and you can really reap the benefits of sort of playing this middleman in rent seeking. A lot of times people call that disrupting, right? So you could disrupt the taxi industry. That's like what Uber did. We're not there, I don't think it's going to. Right? We don't have a platform that's sucking the life out of our industry. And so I'm here, I'm really excited about giving this talk because I want to empower us to not ever get there. Right? I want us to be in a situation where we have a robust, multi-stakeholder industry. Okay? And one more slide to convince you that that's a valuable thing. I want to talk about something called the prisoner's dilemma. And this is the thought experiment in game theory and moral philosophy. And I know nobody likes moral philosophers, but it's a really cool thought experiment. The idea is you and somebody else are collaborators in a crime, right? You're both arrested. And you're both told, if you tell what happened and the other person doesn't, You will go for 8, the other person will go 3 years. You're both told the same deal. You cannot collaborate or communicate amongst each other. If you both tell, you both get 2 years. But if nobody tells, each of you only gets 1 year. So if you do the math, on average, it's better for everybody not to, right? Not to give up the game, okay? But we're an advantage here because we can talk, and we can say, hey, let's build a robust, smart energy market. Let's make sure that we do this thing together. And there's a couple of fun, I put the links down here. I think they're going to be in slides, so you can look them up. But there's 2 really funny stories where university professors taught Prisoner's Dilemma and then said that the final would be graded on the curve. And if everybody got zeros on the final, then everybody would get A's. And so the students all collaborated with each other to say, everybody don't do the final. Right? If nobody does the final, we all get A's. And they were actually able to boycott the final and all get A's by realizing they were in a situation with Prisoner's Dilemma, and by working together, they could all win. So what's the other way? First of all, there's standards, okay? So I love standards. Standards are great. There's a couple of standards in the smart energy space that I'm a huge fan of. CTA 2045, I love CTA 2045. The only disadvantage of it is that it's basically only water heaters, sometimes HVAC, but rarely. The great thing about CTA 2045 is that it implements a standard hardware interface that lets you be totally independent of the backend. It can be Zigbee, it can be Wi-Fi, it can be custom RF, it could be RF to utility grids, right? CTA 2045 gives the most power to the market. Now, in HVACs, you can choose. You can do CTA 2045 or you can do OpenADR. Right? I think is the current regulation. OpenADR is great. The only thing I don't like about OpenADR is it's cloud to cloud, so if you have a local system, it's not as good. Like, so Savant, for example, can do off-grid homes, and like super off-grid. Like, we will helicopter drop a pre-manufactured home with our batteries in the middle of nowhere, no internet, whatever. So, you know, OpenADR, HCA, all those cloud-to-cloud-based integrations just don't work. So we have to have some things that control. CTA 2045 gives us that. And so does Matter. Matter is also a protocol where you can do everything you want. You're using Matter over Thread or Matter over Wi-Fi. They're really wonderful. Next, you know, we have working groups. Meetings like this, they're a wonderful opportunity. I also was sort of blessed with the opportunity to go to a consortium for energy efficiency meeting, I think, here in Dallas last year. That was very cool. If you can go, if you're invited to a CED meeting, I can't recommend it enough. It was wonderful to be in the same room with all the stakeholders talking about different standards and ways to move forward. And finally, just, you know, straight professional collaboration with all of the different things. So finally, you know, I want to thank you all for your attention. I really, really appreciate it. I think that we can sort of take this message moving forward and create more value for the consumer, more opportunity for all of our businesses, more value for ourselves, our shareholders, and provide the best information we can.
Will, for that great presentation, taking a look back in history, which at Parks Associates we especially love. Going back to the late 80s is when Parks was founded by Trisha Parks, and so we love the message about the whole home experience. That's really where the foundation of our work started, way back almost 40 years ago, and it's just great to have a speaker who can look at that history and who has contributed really to the growth and where the industry has taken us all. So thank you again to Savant for your great support. Thank you, Will, and we hope you enjoy the rest of your lunch. We will be starting over here in a few minutes with our next session. So thank you again for joining us.